How are you, dear families of my channel? Welcome to my class. Today I'm going to show how to calculate the mass problem, mass mole problem, and mole problem. These are the parts of stoichiometry. Stoichiometry is a study of the quantitative relationship that exists between the reactants and products which are involved in chemical reactions. It is a study of the amount or the ratio of moles, the ratio of mass, the ratio of volumes for gaseous substances, of reactants and products. So chemical calculations are uh, achieved or attained uh, based on the following two major principles called the composition of any substance, and the chemical equation should be expressed with definite formula, and the law of observation of mass must be obeyed, which means a chemical equation must be balanced. Remember, under these stoichiometric calculations, always you should look at the equation must be found balanced. Molar ratios in balanced chemical equation. Stoichiometry problems of this type are called either mass-mass or mole-mole or mass-mole problems. For example, the reaction that will be taking place between nitrogen and hydrogen to form ammonia is uh, given in such equation. Therefore, this is balanced chemical equation because 3 hydrogens times 2, that is 3 hydrogen molecule, 6 hydrogen. In the product also 2 times 3, 6 hydrogen atoms are found. Nitrogen is a product 2 and nitrogen is a reactant 2. Therefore, the equation is balanced. What information is found here is you can suggest about the 1 molecule of nitrogen react with 3 molecules of hydrogen to form 2 molecules of ammonia, or 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia, or according to the mass interpretation, 28 grams of nitrogen reacts with 6 grams of hydrogen to form 2 times 17, that is nitrogen 14 plus hydrogen 3, 17 times 2, 34. Therefore, 28 grams of nitrogen reacts with 6 grams of hydrogen to form 34 grams of ammonia. Therefore, such information can be extracted or clear while just you are observing the balanced chemical equation. Calculations based on chemical equations or stoichiometry problems are classified into mass-mass relationship or problem, volume-volume problem, and mass-volume problem. These are general classification. The mass-mass relationship. What are mass-mass relationship? There are two methods for solving mass-mass problems. These are the mass ratio and the mole ratio methods. The mass ratio method is the method in which the mass of one substance is given while the mass of another substance is going to be calculated. Example: how many grams of aluminum metal must be heated in order to get 20.4 grams of aluminum oxide? The equation first must be written and must be balanced again. Therefore, 4 moles of aluminum reacts with 3 moles of oxygen molecule to give 2 moles of aluminum oxide. Therefore, there are steps to be followed. You will write X above the required substance and the number value which is given above the given substance, which means aluminum is required here. Therefore, you should write X above aluminum and 20.4 above aluminum oxide. Not only that, also the masses of those concerned substances, the total mass of those concerned substances means the given ones and the required ones must be written below the symbols or formulas. For instance, aluminum which is assigned by X, which means to be calculated, and aluminum oxide, in which the given mass is 20.4 written above it, and the total mass of aluminum here written below it, that is atomic mass of aluminum 27. Its coefficient is 4 times 27, 108, and that of the total mass of aluminum oxide, we have 2 aluminum and 3 oxygen. 2 aluminum, 2 times 27, 54, and 3 times 16, that's oxygen, 48, and here the coefficient 2 multiplies this summation of this result, it becomes 204. Therefore, you will set up the proportion x over 108 is equal to 20.4 over 204. This one will be set up as such. Therefore, what we will be doing now is x times 204 is equal to 108 times 20.4, which means x equal to this value times this value over 204. Therefore, the mass of aluminum that must be heated in order to produce 20.4 grams of aluminum oxide is 20.8 gram. Okay, the mole ratio method is another method of the part of the mass problem, or mole problem, or mass mole problem. In mole mass problems, the mass of one substance will be given the number of mole of another substance will be required, or vice versa. Example: what mass of iron 3 oxide must be reacted to generate 3 moles of aluminum oxide. Therefore, you will write first balanced chemical equation, this ones, and you should write x above iron 3 oxide and 3 moles above the aluminum oxide as follow. You see, x above iron 3 oxide, and the total mass of iron 3 oxide is 160, like this one is 2 iron, 2 times 56 plus 3 times 16 is equal to 160. Okay, the total mass of aluminum here found is 1 mole only. Therefore, 2 times 27 plus 3 times 16, 102. Therefore, you set up the proportion as follow. X over 160 is equal to 3 over the coefficient of aluminum oxide is 1 over 1. You will set up the proportion as such. Therefore, x times 1 is equal to x. 160 times 3 is equal to 480. It will be 480 grams of iron 3 oxide must be reacted. Okay, questions. How many moles of water are required to produce 4.5 moles of nitric acid according to the following reaction? That means nitrogen dioxide reacts with water molecule, gives nitric acid plus nitric oxide, or NO, is formed. Therefore, what is required? How many moles of water? You should write X above water and 4.5 moles above nitric acid. You will just look at these ones. Therefore, the number of mole or the coefficient of nitric acid is 2. You will write 2 above, below this formula, and you will write 1 below water molecule because the coefficient of water is 1. Therefore, you will set up the proportion x over 1 is equal to 4.5 over 2. X over 1 means x. Therefore, the value of x is equal to 4.5 divided by 2, which is 2.25 will be the value of x. Okay, question number 2. How many moles of calcium oxide are needed to react with excess water to produce 370 grams of calcium hydroxide? Therefore, how many moles of calcium oxide? You should write X above calcium oxide and 370 gram above calcium hydroxide, which is given. Therefore, you will write the total mass of calcium hydroxide below the formula and 1 below calcium oxide, because the coefficient of calcium oxide is 1. You will write 1 as it is. Therefore, x over 1 is equal to this number 370 over 74. 370 over 74 is equal to 5. Therefore, the number of moles of calcium oxide needed to react with excess water to produce this much of calcium hydroxide is equal to 5 moles. Okay, in the decomposition of potassium chlorate, how many moles of potassium chloride are formed in the reaction that produce 0.05 moles or mole of oxygen? Okay, therefore, the number of mole of oxygen given 0.05, and what is required is the number of mole of potassium chloride, which is formed after the decomposition of potassium chlorate. Therefore, you should write these 2 below these ones and 3 below oxygen. Okay, 2 below potassium chloride. That means x over 2 is equal to 0.05 over 3. And x is equal to 2 times 0.05 over 3, which is nearly 0.033, like this. Okay, question number 4. How many grams of calcium carbonate are needed to react with 15.2 grams of hydrochloric acid according to the following equation? That means calcium carbonate is reacted with hydrochloric acid to form calcium chloride plus carbon dioxide plus water. Therefore, how many grams of calcium carbonate needed? So grams of calcium carbonate is required 1, and the given one is 15.2 grams of HCl is given. Therefore, set up the proportion as such: x over molar mass of calcium carbonate, calcium 40 plus carbon 12 plus oxygen 16 times 3, 48, it becomes 100. And hydrogen chloride, that is hydrogen 1 plus chlorine 35.5, 35.5 plus 1, 36.5, times coefficient 2 becomes 73. Therefore, 15.2 over 73 is equal to x over 100. X will be 100 times this number over 73. Okay, that's like this one's. X is equal to 100 times 15.2 over 73. 15.2 times 100 means it is 1520 divided by 73. Therefore, the value becoming 20.8 grams. The question 5 says, what mass of nitrogen dioxide is produced by the decomposition of 108 grams of magnesium nitrate? This one is magnesium nitrate. As you know, when it is balanced, it will be having 2, coefficient 2, gives magnesium oxide plus nitrogen dioxide plus oxygen will be formed by the decomposition reaction. Heat decomposition of magnesium nitrate gives these products. Okay, what is given? The magnesium nitrate is given 180 to 82, and the nitrogen dioxide given is X. That means which is required. And the total mass of nitrogen dioxide: 1 nitrogen 14 plus 2 oxygen, 2 times 16 is 132, times the coefficient. The summation of this number multiplied by this value becomes 184. Therefore, the magnesium 24, this one is nitrogen and oxygen inside the bracket multiplied by 2. Okay, nitrogen becomes 14 times 2, 28. Oxygen here inside 16 times 3, so 48. 48 by 2, 96. And 96 plus 28 plus this magnesium 24, and multiplying the results, the summation of these values by 2 gives us 296. Therefore, the proportion will be set up like this: 182 over 296 is equal to x over 184. X is equal to 182 times 184 over 296. these ones. Therefore, the result becomes 113.14 gram of nitrogen dioxide is produced by the decomposition of 182 grams of magnesium nitrate.